I'm not sure if I have like a single big question. I'm just like generally interested, I think, in just like trying to understand like what is happening and like why it's happening. So I'm Neal Dalal. So I'm a cosmologist working here as faculty at the Perimeter Institute. So in cosmology, one of the big questions is just like, what is the origin of structure in the universe? One branch of my work has to do with trying to study conditions that were taking place in the very earliest stages of our universe. Another part, relates to what's called dark matter. So this is a new kind of matter in the universe, which is not something that we've ever experienced here on the Earth, except by its gravitational effects. More recently, I suppose I've gotten kind of excited about, trying to probe black holes using like a new kind of astronomy. This is called intensity interferometry. So perhaps you've heard of like the Event Horizon Telescope. This is a network of telescopes across the Earth, and they combine the data from the telescopes, to give us angular resolution on the sky as if we had a telescope the size of the Earth. In general, for any kind of telescope, like a single telescope or even some array of telescopes, like the angular precision on the sky that we get, it's something like the ratio of the wavelength of light that we're observing compared to the separation between the telescopes. And so for the Event Horizon Telescope, they observe radio waves. And these radio waves have millimeter wavelengths, okay? And so a millimeter compared to the size of the Earth is a really tiny angle. But visible light has a wavelength like thousands and thousands of times smaller even than radio light. So imagine that it were possible to do EHT by using visible light instead of radio light. Then instead of getting this like really blurry image of the black hole, just because the angular, the angular resolution is limited, we can instead get like a megapixel image of the black hole in our galaxy. And so this intensity interferometry, this is a way to do, like interferometry like across the Earth, but using visible light. So this idea was invented like decades ago. Recently, this has been just like revolutionized by the development of these new quantum sensors that are called superconducting nanowire single photon detectors. And we have these new quantum detectors that can measure single photons as they reach our detector, one at a time. And they're capable of measuring the arrival time incredibly precisely. If you measure the arrival times of the photons coming in at the two telescopes, you can use that to do interferometry and thereby reconstruct what the sky looks like with an incredibly high, angular precision. But again, luckily right now, so besides this quantum revolution, we also have this other revolution happening right now, which is the AI revolution. And so one thing that we're doing is to make use of some of these modern AI methods to help us with the data analysis. I am really hoping that I can convince the field to pursue like a large-scale intensity interferometer. Every component needed to make one of these things has already been demonstrated. So really, all that's needed to make this happen is just like collective will. If we could convince the community to really come together, to support something like that, I feel that would be like really transformative, for astrophysics in general.